Okay, so we have a cylinder and a hemisphere involved here. Okay, you should be able to see them up here on the top right. Okay, so the cylinder, we're told, is 66 diameter, which means it's 33 radius. So I'll go 33 and 66. I'll draw that cylinder in its place. Its height 75. Draw the centre of that coming down the middle there. Okay, now we want to draw our cylinder in place here down at the bottom view as well. So I'll start by coming down by 10 millimeters, then by 33. 1, 2, 3, 33. 1, 2, 3, 4, 5, 6, and 66. We'll take our compass. Set it to our size. Okay, so I have my cylinder drawn, and now I want to position my hemisphere. Now, we can draw it initially in the front elevation view because we know that the center point is 15 from the edge of the cylinder. So I can step out 15 millimeters, and that will be the fixed and finished center point of this hemisphere. Okay, however, we don't know where it is in plan view. Okay, now we know it's also radius 40, so we can step out here by 40, set our compass to 40. Now in general what we would do is we would bring our hemisphere in the side-by-side position to the cylinder, and then we bring it down and roll it round. Okay. However, I know that the radius of this hemisphere is 40. I know that its extreme generator is along the XY line, and I know that the cylinder has vertical surfaces. So I can add the two radii together. So the radius of the cylinder is 33 and the radius of the hemisphere is 40. So 33 plus 40 gives us 73. So if I measure out 73 millimeters, that is going to be the position of the center point of the hemisphere as it's in its side-by-side position. And I can rotate it around the cylinder, therefore giving me its position. Okay? So I can then go and set my compass to 40 millimeters, put it on this point here, and drawing in my circle. Now what you should find is both circles. Sir. Yes, lad? Why should you give the second circle? This one? Yeah, because that's what we're at. Yeah, so instead of actually moving this hemisphere out to the side, okay, because it's radius 40, plus radius 33. In the side-by-side position, it'd be radius 33 plus radius 40, yes? Instead of doing that, up here, I just did it down here and swung it around to find my position. So this point is where the fake center point would be. That there would be where the fake center point is, yes? But instead of drawing it and doing work that's confusing up here, I just did it down here. So I stepped out 33 plus the 40 and then swung it round. Because I know that this is the finish line of it. Okay? I'm just setting up my compass to be a better version of 33 millimeters. So I get a definite point of contact. Now, how do I get the point of contact between the hemisphere and the cylinder? Is by joining the center points. Point of contact has to be on the path from one center to the other, and then this is our POC. If I bring that POC up to my plan view, sorry, to my elevation from my plan view, my POC goes there. And that is the two objects drawn. Now, the question does not end there. It says a sphere of 50 millimeter diameter is placed in position C. Here is position C. Okay. The sphere is to be in contact with the other two solids and the horizontal plane. So I know, and I'm going to do this in color, just identify the new information, the challenging part. If the new sphere is of radius 25 or diameter 50, no matter where it goes, as it travels along the table or the floor, if you will, it has to be the center point of that sphere has to follow that green path, doesn't it? If you roll the ball, the new sphere of radius 25 or diameter 50 along the table or the floor, the center point will follow that path. Isn't that right? Now, I'm going to take this new sphere and I'm going to attach it to the cylinder and ignore the hemisphere. And then I'm going to do a separate piece of work and I'm going to attach the new sphere onto the hemisphere and ignore the cylinder. And then I'm going to combine the two of them by rolling them around here and solving it. Now I will finish off this recording, guys, and I'll throw it in the Teams so you can have a look at it. Is that okay? Apologies about being late to class, alright? So, with my radius 40 plus 25, we go to here. Yes.
What's your chess rating?
Oh, I haven't a clue. I haven't played in a long time. I haven't played in a long time, but I'll play you the game sometime, no problem. You can show me the ropes how to do it again. Yeah. Nice.
get it fixed this weekend. Do you want me to do the project on the street?
We'll do what you can in class tomorrow, and yeah, look, just do what you can. Do what you can when you get a chance. Is that okay? See you later. Now I'm going to bisect this angle in here, which will give us a 45-degree angle, so you can use a 45-degree set square either. See you, Dylan. So the center point for this is 25. Out from the side of the cylinder and 25 up from the ground. Or you can bisect the angle of a 45-degree angle, and it gets you the same thing. So any combination of two of those three steps will get you that. This is the sphere in a side-by-side position with the cylinder, so we're going to bring it down to the side-by-side position and roll it round. And what we've done here is we put the sphere beside the hemisphere, bring it down and roll it round. And where the two rolls meet is our finished position, which we can then finish off for both of our views. Now I'm doing this hemisphere or this sphere over here on the left hand side in blue, just so you can identify the different steps between one and the other. Okay, so the other sphere here was done in green, and then this is going to be worked on in blue. So we'll take our center point of our cylinder, add the sphere to it, swing it round, and bring it around to there. So that is swinging around. And so where the two of them meet is our fixed position. Now if we join this point to there, the distance there should be 25, the size of the sphere. So it should be just touching that vertical surface of the cylinder. And then it will overlap the hemisphere. So joining up the center points to get the point of contact. We know where our fake point of contact here is P1, and we can swing that around. So the fake point of contact here in the side-by-side position is P1. We want to swing it around till it meets that blue line, and that's the finished point of contact. Now I'm going to take my radius of 25 of this hemisphere, or this sphere C. I'll draw it in here. So this is our POC2. We need to bring that sphere up. POC. Right there is POC2, and I know that from here. And now we're going to join these two centers together. And bring this up. POC3. POC3. And then what we'll do is, to clarify, we will give this some colour. We have a blue cylinder. We have a pink hemisphere. And I'm just going to go with a green new sphere. Okay, so that's that done, and that's the solution. Okay.